Welcome to this tutorial on Elastic Load Balancing. Commonly known as ELB, this is part of our AWS networking series. In this video, we'll explore how AWS load balancing services help distribute traffic and ensure high availability for your applications. Let's get started with understanding the fundamentals of load balancing in Amazon Web Services. Load balancing is a core concept in cloud computing that helps manage traffic efficiently. It automatically distributes incoming application traffic across multiple targets. These targets can be EC2 instances, containers, or IP addresses. Think of it as a traffic controller that ensures no single server gets overwhelmed with requests. Instead of sending all users to one server, the load balancer spreads them across multiple servers, improving performance and reliability. Elastic Load Balancing offers four major benefits. First, it provides high availability by distributing traffic across multiple availability zones, ensuring your application stays online even if one zone fails. Second, it offers scalability, automatically adjusting to handle varying traffic demands without manual intervention. Third, it enhances security through integration with AWS security services and support for SSL and TLS encryption. Finally, it includes health monitoring capabilities that detect unhealthy targets and automatically route traffic only to healthy servers, preventing failed requests. AWS provides three types of load balancers, each designed for specific use cases. The Application Load Balancer, or ALB, operates at Layer 7 and handles HTTP and HTTPS traffic. The Network Load Balancer, or NLB, works at Layer 4 and manages TCP and UDP traffic. Finally, the Gateway Load Balancer, abbreviated as GWLB, functions at Layer 3 and processes IP packets. Each type serves different networking layers and application requirements, which we'll explore in detail next. The Application Load Balancer is designed for modern web applications and operates at Layer 7, which is the application layer of the OSI model. It intelligently routes traffic based on content such as URLs, headers, and HTTP methods. ALB supports both path-based routing, where different URL paths go to different servers, and host-based routing, where different domain names route to different targets. This makes it perfect for microservices architectures and container-based applications. It also has native support for WebSockets and HTTP version 2 protocol, making it ideal for real-time applications and modern web services. The Network Load Balancer is built for extreme performance and operates at Layer 4, the transport layer. It can handle millions of requests per second while maintaining ultra-low latency, often in the microsecond range. Unlike ALB, NLB makes routing decisions based on network information rather than application content. It supports static IP addresses for each availability zone, which is useful when your clients need to connect to fixed IP addresses. This makes NLB perfect for gaming applications, Internet of Things devices, and any real-time application that requires the fastest possible response times with minimal delay. The Gateway Load Balancer is specialized for deploying and scaling third-party virtual network appliances. It operates at Layer 3, the network layer, and is specifically designed for security use cases. GWLB helps you deploy firewalls, intrusion detection systems, intrusion prevention systems, and deep packet inspection tools. It combines the functionality of a transparent network gateway with load balancing capabilities. GWLB uses the GNEV protocol on port 6081 to encapsulate and forward traffic. This makes it essential for organizations that need to inspect and secure all traffic flowing through their network using specialized security appliances. Selecting the appropriate load balancer depends on your specific application requirements. Use Application Load Balancer when building web applications or microservices architectures that need intelligent content-based routing. Choose Network Load Balancer when you need high performance, low latency, and can handle millions of connections per second, such as for gaming or financial applications. Select Gateway Load Balancer when you need to deploy network security appliances like firewalls or intrusion detection systems. Understanding these differences will help you architect more efficient and reliable applications on AWS.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.